Normal distribution. So we've done some of this in year 10, so this is going to be a bit of revision for it. We have basically all naturally occurring phenomena that you can measure are normally distributed. So you have height of a person, height of a tree, weight of a table, all right, things that we make, they're all approximately normally distributed, which means we have a mean, all right. In our example here, the mean is 175 centimetres, and we have a standard deviation of 8 centimetres. So you'll notice if you're looking at the image in the top there, we have here the mean plus 1 standard deviation. So 175 plus 8, that's going to be 183. We have the mean plus 2 standard deviations. So 183 plus 8, that's going to be 191. And the mean plus 3 standard deviations, 199. And what you notice is the further away you get from the average, the lower the probability of that event occurring. Of course, that's true. And the same going this way. We have the mean take the standard deviation, 167, 159, 151. Okay, so 175 plus 8, plus 8, plus 8, 175 take 8, take 8, take 8. That's how we generated this distribution. Now it's set up in a way that all distributions, they're symmetric about the mean, okay, so you have 50% of the data is below the mean, 50% of the data is above the mean, and you have 34.13% of the data between the mean and the mean plus 1 standard deviation, okay? And so I've filled in those percentages on this table there. You can see that's 13.6, and this is 2.13, and this is like 0.59, or something like that, percent. It might be best illustrated in your textbook. Okay, part A, draw the distribution, done. Part B, determine the probability of a year 11 having a height between 167 and 183 centimetres. So that is this event here, okay? That is this event here, isn't it? Between 167 and 183, so 1 standard deviation below, 1 standard deviation above. The probability of this occurring is 34.13% plus 34.13%. We've got 68.26% chance of that occurring. Now the way we would write that event out, okay, is it's the probability of the event being between 167 and 183. Okay, so the probability of this event between 167 and 183 is 68.2%. Now we generally don't write probabilities as a percentage. When we're doing the calculations later in our calculator, we will just dish them out as a probability, and that's just dividing it by 100. Okay, part B. Part B2, less than 167 centimetres. So now it's like anything below 167. What's the probability of this event here? Okay, all of those probabilities added together. So we're just going to add up. We've got 13.6% plus 2.13% plus 0.59%. All right, and so the way we're going to write that, so that's part 1, here's part 2. Probability of it being less than 167. 13% plus 2% plus 0.59%. It's, what is it, 16.4 or something like that. I'm just going to put 16% for now as an approximation, or as a probability 0.16. Okay, and then more than 183. Okay, so more than 183, that's this event here. All right, again you can see it's the same, 13.6% plus 2.13% plus 0.059%. So probability of the height being larger than 183 is pretty well the same. All right, so that's enough to get started. We can look at how we use that technology either later today or tomorrow. The questions in the textbook, you don't need to use your calculator for. The questions in the workbook, okay, these ones here, we will be using our calculator for a little bit tomorrow. Okay? So refer to the distribution, use those. Good luck.